Today we're looking at is section 5.1, perpendiculars and bisectors. The goals for today are to use properties of perpendicular bisectors and also use properties of angle bisectors to identify equal distances. We have a couple different vocabularies that you have to know. Perpendicular bisector. The perpendicular bisector intersects a line segment, it splits it into two equal parts, and also forms a 90-degree angle. So a perpendicular bisector, best, look at a picture, we have a line segment, and then we have a line going through this segment, meeting at a 90-degree angle. And of course, the perpendicular bisector says that these two segments are going to be congruent. If I have equidistance from 2 points, it's pretty much taken what we just did in the perpendicular bisector, and it's saying that if we have equidistance between 2 points, that is going to be the same distance between both of these points. If you have a distance from a point to a line, distance from a point to a line is defined as the length of the perpendicular segment from the point to the line. So in other words, if I have a line and I have a point, the way that we find the distance between this point and this line is by drawing the perpendicular bisector. Not even the bisector, just the perpendicular line. So it's going to be a perpendicular line, and this right here will be the distance to the line. Now we can draw other ones, but it has to be a 90-degree angle because that's going to be the shortest amount from the point to the line. If I have equidistance from 2 lines, that's when a point is the same distance from one line as it is from another line. So equidistance from 2 lines, if I have 2 lines, equidistance from 2 lines is when I have a point right here, that this distance and this distance will be the same. So if I know that I have a point in the middle and it's equidistance from both of my lines. All right, so we have a couple theorems you have to know. First off, if you have the theorem 5.1, which is a perpendicular bisector theorem, what I like to do is I like to think about this as a radio tower. If you have a radio tower and you have 2 guy lines holding this up, then we know those guy lines or those support lines need to be equidistant away from the point. If it's not equidistant, then the tower is going to lean one way or the other. But we want it to be straight up and down. So, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So if line CP is the perpendicular bisector of AB, then CA equals CB. We also have theorem 5.2, which is the converse of the perpendicular bisector theorem. So it's going to be going in the opposite direction. So if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. In other words, if DA is equal to DB, then D lies on the perpendicular bisector of AB. You can also think about this in terms of a bow and arrow. If you have a bow and arrow and you pull back on the bow and arrow, you want it to go straight, so you're going to have to pull back straight back, meaning that this and this length will have to be the same. If you pull over here, the arrow is going to end up going in this direction. If you pull over here, it's going to go in this direction. So we have to pull back straight back so that the strings are the same length. That's how we make an arrow go straight. So, example 1, using perpendicular bisectors. In the diagram shown, BE is the perpendicular bisector of AC. what segment lengths are equal. So right away, since we know BE is the perpendicular bisector, we know that this length and this length are going to be congruent because it bisects AC. So because BE bisects AC, I know that AE is equal to EC. All right, because B is on the perpendicular bisector of AC, you can use the perpendicular bisector theorem to conclude that CA, no, not CA, AE is equal to EC. All right, question 2, letter B, AP is congruent to CP. So it's telling us AP is congruent to CP. What can you conclude about point P? Well, this uses the converse of the perpendicular bisector theorem, and we know because AP is congruent to CP that AP is equal to PC. Using the converse of the perpendicular bisector theorem, you can conclude that P lies on the perpendicular bisector of EB. We also have some other theorems you have to know. For example, you have theorem 5.3, which is the angle bisector theorem. If a point is on the bisector of an angle, then it is equidistant from the two lines of the angle, or two sides of the angle. I shouldn't say rays or sides. We're going to say sides of the angle. So, if the measurement of BAD is equal to the measurement of DAC, then DB is equal to DC. Theorem 5.4. If a point is in the interior of an angle and it is equidistant from the sides of the angle, then it lies on the bisector of the angle. So if we know this and this are congruent, then we know that the angles are also congruent. Therefore, if DB is equal to DC, then we know that the measurement of BAD is equal to the measurement of CAD. So in a baseball field, in a baseball field, not sure if I got cut off yet on the last one, so I'm going to show you it to you really quick. Pause, feel free to do that. On the last one, we have a baseball field, so use the diagram of the baseball infield shown at the right. What can you conclude about the measurements of SHF? So let's find what they're talking about. S, H, and F. So what can I conclude about this angle? So what I'm going to do is I'm going to quickly draw a quick angle just so I can see what that looks like. Make it dotted. I'm looking for this angle right here. It's always good to identify what you have. From this diagram, you know that point blank is the interior of THF. So if I have THF, I know the interior of that is going to be point S. And ST is equal to SF. Since it's given to us that these two lengths are congruent. From the blank theorem, you know that S lies on the angle bisector of angle blank. An angle bisector divides an angle into two congruent angles, each of which has length, the measure of the original angle. So, from the angle bisector theorem, actually it's probably going to be, since we know this and this is going to be the converse of the angle bisector theorem. So we're looking at the converse of the angle bisector theorem. You know that S lies on the angle bisector of THF. An angle bisector divides an angle into two congruent angles, each of which has the has half the measure of the original angle. So the measurement of SHF is going to be 1/2 of 90 degrees, or 45 degrees. So the measurement of SHF is 45 degrees. All right, on your own, let's see if you can do number 1. To find the answer in the diagram, PQ is congruent to RQ. So I'm going to mark PQ and RQ. What conclusion can you make about point Q? Can you conclude that S is on the perpendicular bisector of PR? Explain. Well, since I know these two angles right here, most likely what I'm going to be doing is looking at the converse of the perpendicular angle. So if I know that these two angles are congruent, I can say that this angle measurement, in the diagram PQ and QR, what conclusion can you make about point Q? What can you conclude? Well, we should know, actually it's going to be the converse of the perpendicular bisector theorem, so that if we know that this length and this length are congruent, then I know that this length and this length are also congruent. I also know that this is a perpendicular line. So can you conclude that S is on the perpendicular bisector of PR? Yes, I can. So by using the converse of the perpendicular bisector theorem, we know that this doesn't have a point, so let's give it a value of x. We know that px is the same as xr. All right, number 2. In the diagram D, D is on the angle bisector. Is on the bisector of angle ABC. So I'm going to draw a quick line just so I know that this is my angle bisector. What is DC? So I want to figure out what the length of DC is. So if I know that this is the angle bisector, then the one thing I know is, based upon the angle bisector theorem, since this meets at a 90-degree angle and this meets at a 90-degree angle, that these two lengths have to be the same. Therefore, if this is 6 and this is 6, I know that DC has to be 6.